Hi, I'm Akshay, and in this part we're going to study about phasors. Now, this is one topic which is difficult for most of the students to understand, and it's just because they don't really, even after solving questions, they don't understand what phasors are. It's helping them to solve, but they're still not clear on the context that why do we have such a quantity we call phasors, and I will try my best to explain that to you in this video. So first of all, let's just see what they do and then try to understand that what they are. Let's try to see what they do and then we'll see what they are. So suppose I have a AC circuit in which the current in circuit is varying as I is I naught of cos omega t. If I have such a circuit and I want to observe this graphically, so you'll say that okay, so it is varying with time, the current is varying with time. So if we draw IT curve, so the current shall vary with just like a cos function. So it's going to vary like this, and this will be our current. This will be the variation of current with time. Okay, fine. But yes, but this does not give me any true picture. Can we construct a way to understand it in a more very simplified manner? So that is why the phasors were invented. Let's see that, okay, if we have a coordinate or whatever, we are not labeling our coordinates, we're just trying to understand what the phasors are. If we have a vector, suppose we have a vector of length, if we have a vector of length I naught and is rotating with omega, rotating with angular frequency omega, is rotating with omega, then let's see, and it has its one end at this origin of this the system I have drawn here. So it has one of its end here. We'll see that it rotates. It has a length of I. Length is I. It is rotating with constant omega. Say after some time t, it rotates by this angle. This is theta. So what we can write is theta will be definitely omega t. This is constant angular velocity. Theta after time t, by which theta, how much theta it has rotated can be directly written in terms of omega t. And if we try to see the projection of this on to this axis, what is the component of this vector along this axis right now? This value will be I cos theta. Cos component along the theta is I cos theta. So this will be our I cos of theta, which can be written as I cos of omega t. Remember, I'm just writing horizontal component of vector I, rotating vector I, right? So we see that this equation right here and this right here are the same. That is, the behavior of this can predict the behavior of our equation of I is equal to I naught cos omega t, because the behavior of the projection on horizontal axis is same as of the current. So we can try to study this by studying our rotating vector I. We can study, there exists a relationship between these and these two, and that relationship is such that the horizontal component of our rotating vector gives the same relationship as our current. So this is one thing which is clear, and the projection of phasor is why we choose to use cosine function rather than sine function. It's just a way to use cosine because component would be easier to break and it will be directly horizontal projection. So now let's come back to that question. This is what we wanted to study, that what does a phasor do? A phasor simply creates a relationship between an entity to another entity, and which may simplify our calculation. But what a phasor is, I've still not answered that question, so I'm going to answer that question now. So what is a phasor? what is a phasor, right? So what is a phasor? Is it a real quantity? Is it a real quantity, or is it just some hypothetical concept that we imply to reduce our calculations? And as saddened as I am to say to you that yes, it is not a real physical quantity, and yes, that it is a non-physical construct, or it's a mathematical construct that we deploy to make our calculations easier. But this is because right now we're studying physics, and we're trying to relate physics to our physical environment, and we don't see that. Yes, but when we go to our quantum mechanics, and when the dimensions does not remain three dimensions, time also comes into, even at our classical scale also, time comes into as a dimension. And if we solve the equations involving all four direction or more, the concept of phasor becomes very much relevant to us, because then the space does not remain a simple space with real quantities. It becomes a space with complex quantities which have iotas, and which is just a mathematical construct, and we can never comprehend the fact that iota exists in the space, right? So it's a mathematical concept which allows us to understand our physical nature, and it eventually also helps us to just simplify our calculations. So the phasor, it is not a it is not a physical quantity. Yes, it is not a physical quantity, a real physical quantity, a real physical quantity. By real physical quantity, what I mean here is, like, velocity is a real physical quantity, we can observe it very well. Then momentum is also very real physical quantity. Electric field is a real physical quantity, we measure it, but we cannot measure a phasor, we cannot see a phasor. So it's not a physical quantity, it's just a geometrical construct. It's a geometrical construct. By this I mean that it's just a way, something we have invented for by ourselves to minimize our calculation, and it works. We found that. Does it work in all the situations? Yes, it does. So we can prepare an analogy between two different particles, which and we'll study the behavior of one particle, which is this, which is easier to study, and we'll apply the same logic for this, and we find that the same equations comes out right for this particle, for this element as well, or for this component as well. So it's just a way to analyze physical quantities. It is a geometrical construct for analyzing physical quantities which vary sinusoidally, This must be pretty clear, because since we are taking the components of a vector, this is horizontal will be cos theta, vertical would be sin theta. So basically this construct will give us information about sin theta and cos theta, that is about the physical quantities which vary sinusoidally, right? And what phenomena which we regularly see which have all these sinusoidally varying quantities? There's SHM. In SHM, so SHM, the motion of the particle varies sinusoidally with time. So we can say that in SHM we can employ our phasors. In AC current, in AC circuits, alternating sources, there where the current or the voltage source varies sinusoidally, we can employ this. And some other situations where we may find that something varies sinusoidally, yes, right at the point you infer, right at the point that you understand that something is varying sinusoidally, you can always analyze that situation by the use of phasors. So sinusoidal quantities, they have phases with them. What a phase is, the phase which we generally refer to is this angle made with the horizontal axis, which is theta here. So theta is the phase, this is the phase. Or for this mathematical equation which we written is omega t, anything inside the sinusoidal function will be the phase. This is the phase. Okay, this will be the phase. And if we employ this method, we'll see that the addition of two quantities, let us see by one example how does it affect. So if we have a current by due to one at one junction, current is coming I1, and from here the current that is coming is I2, and we'll see that the current that goes here will be I1 plus I2. Say I1 was something I1 dash cos omega t, and I2 was something I2 dash cos of omega t plus phi. That is, both of them have the same frequency, the same angular frequency, but have different phases. Phase of this is omega t, and for this part, the second one, the phase is omega t plus phi. This is the angle. So what will be the value of I1 plus I2? That's our question. So let's see what will be the value of I1 plus I2. So this will be I1 dash cos omega t plus I2 dash cos omega t plus phi. Okay, so this is one thing. So what we'll do is divide in and multiply by under root of I1 dash square plus I2 dash square. Cos of omega t plus I2 dash divided by I1 dash square plus I2 dash square to the square root. Cos of omega t plus phi multiplied by under root of I1 dash square plus I2 dash square, 2 dash square. Suppose if I say this is my sine phi, or let us try to say in terms of cos itself, this is my cos of alpha, then this directly becomes sine of alpha by direct trigonometry, so we are not going into that. So I can directly write this as cos alpha cos of omega t plus sine of alpha cos of omega t plus theta, right? So what we can do is, this is cos alpha, this is cos of omega t plus then sine of alpha bracket cos omega t cos theta minus sine omega t sine theta. So this becomes cos alpha cos of omega t plus sine alpha into let's call it I naught dash into I naught dash into I naught dash sine alpha cos omega t cos of theta minus sine alpha sine of omega t sine of theta into I naught. Again, now it becomes really difficult for us to solve this. Now it's not that difficult if we'll get into a lot of complications here. Now this cos omega t can be found out common in these two, and what we will be left with will be cos of omega t bracket cos of alpha plus sine of alpha cos of theta minus sine omega t bracket sine alpha sine theta, and into I naught. And we'll go on to simplify this until we reach a calculation, or we reach a point where it is simple. So this is one thing. So the other way is to this continues, and we'll eventually find out the value of this, and it'll just take some time. So let's try to understand what does a phasor do. So we see that the phase difference of these two varies by phi. So if I'm in the phase plane, if I'm trying to draw these vectors in phase plane, let's try to draw these vectors. Okay. I1 dash, if it is in this direction, this is I1 dash, this is I1, and let us say that I2 I2 is also let's see, the phase difference between I1 and I2 is clearly visible, that I1 has a phase of omega t, I2 has a omega t plus phi. So this is I1 and we can say it has a phase of omega t. It has a phase of omega t. So let's write that phase as omega t. And then we have our I2 which has a phase of, we have I2 which has a phase of, the length of I2 would be I2 dash. This is I2 and the phase of this will be phi, which is phi greater than that phase, and we have to add these two. So it's just like adding two vectors. So I1 plus I2 would be nothing but adding these two vectors. So addition of these two vectors will directly yield us under the root of I1 square, I1 dash square plus I2 dash square plus 2 I1 dash I2 dash cos of phi, because the angle between them was phi. So this will be the length of this vector, which we would have found by simplifying this equation. And what will be the phase of the final vector? The phase will be omega t plus the angle made with the I1. So what is the angle made with I1? By the resultant, angle made with I1 is, suppose this is angle alpha, or we've already used, this is, let's say this is angle gamma. So tangent of gamma would be I2 sine of phi divided by I1 plus I2 cos phi. That will be our gamma, because this is basic vector algebra, which we remember the formula. So that is to say that if I2 becomes 0, if I2 is 0, the gamma would be 0. Yes, there will be no addition. And if phi is 0, then again gamma would be 0. So this is the correct notation. And the angle, the phase of our I1 plus I2 would be, omega t plus tan inverse of gamma. This we can write as our phase, omega t plus tan inverse of gamma.
Oh, look what I did over there. I had to write omega t plus gamma, but somehow I ended up writing omega t plus tan inverse gamma. Please make sure that the quantity that I wanted to write was omega t plus gamma. It's not tan inverse gamma, it's just gamma, because the angle made by the resultant with the horizontal line is omega t plus gamma.
And we can directly write the equation of our final term. Suppose this will be the this is our the amplitude of current I1 plus I2 I double dash. So we can write, and this will be, suppose this this quantity we write as something else, let us say delta. So we can write that I1 plus I2 will be in such a form, I1 plus I2 will be I double dash cos of delta. That's it. As simple as that. We can write that. Or otherwise we would have gone on to solve all these equations. So that is the beauty of these phasors, and they will make our calculations and everything very easy for us. And we have to remember just two things, that they are rotating vectors, which we have written. They are rotating vectors. It is a vector that we have assumed, so we have to add them vectorially. I've added here vectorially these two quantities, and then we have to understand what the phase is. And definitely, mind my words, they will simplify your calculation to an extent you can never imagine. At least for IIT JEE they will do that. Okay, so